First, I want to thank you guys for having us here. The event here is fantastic. I was outside earlier today. The views are incredible. Muscat's a beautiful location for this event. Today, I thought we would take a different approach to what we've been talking about. Well, it's not really different. It's kind of quite similar. I'm a pacer, by the way. I might be annoying to some because I like to move around a lot. I can't sit still. So today we're going to talk about different things that we're seeing in a changing world. We continually talk about inflection points in networks. What's funny now is I think we've hit multiple inflection points at the same time within networks. Right now, we're actually at a point where demands are outpacing capacity. We used to always have enough capacity to meet demands. Now we're at a transition. We're actually seeing demands truly outpacing capacity, and we need new ways to generate new capacity. Our friend Shannon keeps getting in the way. Can't fire him, got to work with them. At the same time, we're seeing data center explosion take place, over 11,000 data centers. 11,000 data centers, over $600 billion spent on cloud and digitization in 2023. And I would argue it's not done, not even close. We're now moving away from just single cloud. We're moving to hybrid cloud. We're moving to multi-cloud. It's changing completely how we build networks. And at the same time, we're getting a steroid boost from AI. We all talk about AI. I heard the previous panels. I guess they weren't allowed to say AI. I say AI a lot. AI to me is going to be a big boost. If you look at today, we've always said video is going to drive bandwidth. Video is going to drive capacity, virtual reality. Now, if I take my video, if I take my virtual reality and I hit it with a shot of AI, the bandwidth goes through the roof. I have to reinvent my network. I have to rethink on what I'm going to do in my network. You hear all the buzzwords, inference, training. Where does it all take place? All of this is driving us. This is a major cliche, but I like it. It's driving us to reimagine our networks. We cannot build networks the way we do today. It was kind of brought up in the panel earlier. How do I look at the network differently? Things are changing. Artificial intelligence not only could drive bandwidth, if you think about it. I think they were saying today 2/3 of traffic will be AI driven, 2/3 of traffic. If you put that in perspective, 2 zettabytes of traffic exchanged a month. 2 zettabytes is 2 trillion gigabytes a month of traffic. It's changing how we work. AI is changing how we operate networks. It's changing how we build networks. We need to rethink the whole process. In the past and today, we typically look at networks as disaggregated networks. I have a submarine network. I have a terrestrial network, but I also have this metro network. We can't look at networks the same way. Networks are typically hierarchical in nature. It's not efficient. It's not effective. I need to change how I build my network. I used to build OTN switching into transponders into my ROADM network. Additional layers in my networks, additional costs, additional power, additional real estate. Why do I need to terminate all my services at the cable landing station? We just said $600 billion is being sent on cloud. Traffic is located to data centers. Why don't I change how I look at that? Why don't I do an express through? Why don't I reduce layers in my network? What's driving this capacity? It's not OTN traffic. It's not legacy traffic. It's cloud traffic. It's enterprise cloud. It's video, it's AR, it's all cloud driven, it's all cloud based. I have to get my traffic to the data center. In the previous panel, one of the speakers, I think it might have been Alan, mentioned that when I hit my landing station, I might hit multiple data centers. How do I get to those data centers? I don't need to do a regen everywhere I go. Technology today enables me to expand how I look at networks, how I build networks, and how I operate networks. The hierarchical model isn't needed anymore. We need to look at disaggregation of what we do within the data centers, what we do within the cable landing stations. At the same time, we look at integration. What role will pluggables play in the network? What role do embedded solutions play in the network? Now we can terminate in the cable landing stations, or we can pass through into the data center. Check. No issues. We can do that today. Coherent technology, we all know this. Coherent technology has been around for a long time. It extends our reach. We can go directly to the data center. We can glass through the cable landing station. One of the key things we need is more capacity. Now, you can make arguments that, oh, that's no problem. Let's buy another transponder. Remember our friend Shannon, we can't fire him. I can't just buy another transponder. My capacity is a function of my bandwidth and a function of the noise within that bandwidth. I need new ways to get to the capacity. These new ways come from a form of spectral expansion. Why do I need to confine myself to a set spectrum? I don't need to build a network the way I built a network yesterday. I'm building a network for tomorrow. I think someone said on the panel earlier, they were meeting with Saudi, and the person in Saudi stated what comes after AI. That's what we have to build a network for today. I don't put a network in the ground thinking that I get a 2-year life cycle. You're putting networks in the ground expecting to get 10 years, 15 years, whatever that number is. You need to build for spectrum and capacity today. You have multiple technologies to choose from, embedded solutions, pluggables. What is the optimization I'm doing for my network? One solution does not fit all. Zoe in their terrestrial network might want to run pluggables in their network. I don't want to put words in Zoe's mouth, but some other customer might want to run embedded. Depends on the optimization you're looking to achieve. Are you looking to optimize spectral efficiency? Are you looking to optimize cost, power, and real estate? Your hands shouldn't be tied. Sudhir earlier used a word I liked, I think cooperation or something like that. I thought it was a good word because you need an underlying open network. We can no longer build these closed systems. We can't build these perceived open networks. We need to build open networks. Open networking isn't just taking an interface, plugging it into a ROADM and saying, yeah, there we go, I'm open. Open networks means I'm going to plug an interface into it, and I'm going to carry the service from point A to point Z, and at the same time, I'm going to manage that service. At the same time, I'm going to have open APIs northbound, allowing me to control that service how I want to control that service, not how the vendor tells me to control the service. I need to build my networks today that is going to be open. That's going to let me choose. Do I want to run a hop-to-hop network built on pluggables, or do I want to run a spectrally efficient network built on embedded solutions? I decide that, and I don't get locked in. We hear multiple people say that no worries, we're just going to keep increasing our transponders. We're going to go from 100 gig to 200 gig to 400 gig. We getting capped. If you think about it, back when I started, without giving my age, I was building 32 channel DWDM systems with 100 gigahertz space. What happened? We needed more capacity. We were doing 10 gig direct modulated services. I needed more capacity. What did I do? I went to 40 channels at 100 gig in the C-band. Now, different vendors had already deployed new solutions built on 32 channels. So what was it? No, 40 channels will never work because I just built a new solution. It's called lock-in. Well, we proved 40 channel systems work. In fact, we proved 48 channel systems at 100 gig work when we went to extended C-band. But what ended up happening is we quit investing in spectrum. Why? This thing called coherent technology. I went from 10 gig to 40 gig. Then I doubled, more than doubled, 2.5 times it to 100 gig, doubled it to 200 gig. Did I say that right? 40 gig to 100 gig, 100 gig to 200 gig. Then I went to 400 gig. Then I went to 800 gig. Now I'm at a point where I'm running at a spectral efficiency. Something has to give more capacity. We already said demand's outpacing capacity. Why don't I look at the past? What did I do in the past? I expanded spectrum. Why not use subsea? I have that spectrum there. I can increase spectrum. I can increase my capacity by 27%, 6.1 terahertz by going subsea. I can do that today. I don't have to wait till tomorrow. I can deploy that in my network today. And I can operate my pluggables, or I can operate my spectrally efficient embedded solutions over that network. I can take my cable landing station where I have multiple cables coming in, and now I have the capacity in my terrestrial network to carry that service all the way to the data center. But we can't stop there. Super-C is fantastic. Super-L's fantastic. New data rates are great. As I'm introducing these new data rates, what am I doing? I'm expanding the baud rate. By expanding the baud rate, what am I doing? Reducing the channel number, which is forcing me to do parallelization, more OLS systems, more cables. So I have to look at new technology. I look at SDN. What about new bands? What about the S band? What about the E band, the O band? There's new bands that are available to us. There's new cables, hollow core, multi-core. We need to investigate those new services, but at the same time, it all starts with the expansion of my spectrum. I have to take advantage of what's available to me today to ensure tomorrow I'm not stuck. One of the key things we have to ensure, there's a major CTO of a major Middle East operator who has this belief that when I expand from the C to the L and when I restore, it must be hitless. That's not new. We know it has to be hitless, and it will be hitless, and we make it hitless. You can do that today. It's not tomorrow. It's today. It's a requirement. You're not going to risk having service interruption by adding the C-band. You're not going to risk service interruption by having a switch take place in your network. We want to be sure it's hitless. We've demonstrated repeatedly it's hitless. You can see it there from a single channel we used, and one in the C, one in the L, and forcing a switch take place completely hitless transition. But what about pluggables? What role do pluggables play in networks? I was at SNW a year ago, and I talked about pluggables for subsea, and I got a lot of dirty looks. If you think about it, 400 gig ZR, March 2020, defined 80 to 120 kilometers. September 2020, ZR plus 400 gig, defined up to 1,100 kilometers. XR Forum, Open XR Forum, demonstration of 400 gig over 2,000 kilometers in less than a year after ZR plus. 2,000 kilometers at 400 gig in a live terrestrial network. 800 gig, Open ROADM. PCS, probabilistic constellation shaping mixed with OFEC. 800 gig, over 1,500 kilometers in a pluggable. Throw Raman into it, we get closer to 2,000 kilometers in a pluggable based on terrestrial type distances. What role will pluggables play? I think we're going to continue to see the role of pluggables expanding. I want to allocate, if I'm building a data center, if I'm building services to a data center, if I want to take 800 gig to a data center, I want to allocate all that power. If I'm building a 1 gigawatt data center, I want to allocate that power to compute. How do I make my money if I'm operating a data center? I do it on compute. I want as minimal power allocated to all the components outside compute as possible. What's one optimization I can do? Pluggable technology. We're not talking about inside the data center, but there's also other optics you can do within the data center, which we're not going to discuss today. But how do I allocate that capacity? I go to pluggables. I do integration. I eliminate layers. I get rid of this old hierarchical model that people are fond of, the OTN layer, down to the transponder layer, down to the ROADM layer. We're carrying a service. We're paid to take a service from point A to point Z. That service originates where? It originates on a router. Plug the pluggable in the router. Go 2,000 kilometers. Save cost, save power, save real estate. But what about subsea? Last year when I asked this question, I got dirty looks at SNW, so I'm not even going to ask it here just in case I get dirty looks here. But pluggables have a place. If not at subsea, what about the cable landing station? Again, not to pick on you, Alan. I think in the previous session, you mentioned that as all the physics you've learned, you can't switch the color of lights without having a medium to do it. Well, why not a bay of pluggables? If I can go that reach within that form factor of a QSFP DD and OSFP, OSFP, if I can get that reach in that form factor, in that power envelope, why not mix that with a ROADM? Integrate pluggables with a ROADM, and now I can switch to any data center, any wavelength, anywhere after my cable landing station. But artificial intelligence, is it hype or is it real? Multiple views. I think it's obvious. I don't know. At least I think it's obvious. I don't think it's hype. I think AI is real. AI is going to drive a lot of bandwidth across our networks. Even our existing applications will transition to AI, and it's going to continue to ramp up bandwidth. Remember, 2 zettabytes of traffic a month exchanged. Signal AI is at the conservative end of the scale. They believe AI traffic is basically stay within the data center, and it's going to explode. If I look inside the data center, the amount of optics that are going to go inside the data center is going to be ridiculous. If you compare it to DWDM optics, what's happening inside the data center, orders of magnitude more optics inside the data center. Now, inter-data center demand will rise, and more so due to power and compute. So I'm going to have to shard at my data center, at my servers. I'm going to have to shard the capacity, and I'm going to cluster it. If I have to shard across data centers, it ends up causing more traffic according to Signal AI. Now at ECOC, if I talk to Meta isn't as conservative. Meta says it's already driving 30 to 100% traffic depending on the location in their data center demands. They're seeing massive growth. In fact, one of our customers in the United States, they're not getting requests for 400 gigs. They're getting requests for 300, 400 gig wavelengths for different applications. They're changing the definition of colo spaces. They're changing the definition of old meet me rooms and turning metros into meet me rooms and having interconnected to core networks to take customers directly to the data center. Why go to an intermediate location if my destination is the data center? Then I add multi-cloud to that. Then I add AI on top of that. The bandwidth will continue to grow. But it's not just bandwidth that will grow. AI is going to enable us to do multiple things. It's going to enable new efficiencies with new operational models. It's going to allocate new network-based solutions. Picture the cable as a sensor. We've already done that. We've already looked at that in subsea applications where we looked for seismic activities using vibrations in the fiber. What else can I get from the network? What if I take sensing, mix it with machine learning? We were able to classify different vibrations according to frequency and identify what caused that vibration. By using the cable sensing and a machine learning algorithm in order to detect and classify what the vibration effect was. But from an operational perspective, you can gain in the order of, depending on the different customers we talk to, 25 to 40% efficiencies in your network. From new planning and capacity optimization, think about fragmenting your network. We just said we're going to go cable landing station directly to the data center through a terrestrial network. If that's a mesh network, I have the risk of fragmentation. If I can predict what my future growth is and run a defrag algorithm based on past traffic demands. When I used to, if you remember in the good old days when you defragmented your PC, you did it every week, every month. Well, your network also needs defragmentation when you get into a mesh network. But if I can learn my past traffic, predict my future traffic, I can build a pretty efficient defragmentation algorithm. I can build new optimizations. How much margin do we build into our networks today? Why can't I reuse that margin? If you think about it, if we put 3 dB of margin into your network today, that's double the capacity. If I can anticipate an event taking place in my network, can I push my margins? Can I gain more capacity in my network by simply understanding my network traffic patterns? Predictive maintenance, knowing when I'm going to have to do an upgrade, knowing when I have to reroute traffic away from a ROADM because I have to do service to it, anticipating traffic spikes and anomalies, preventing me or timing the event to take place. We worked with one customer where they used to do maintenance windows at 2 in the morning. Now, in America, in the US, 2 in the morning is not a good time, it turns out, to do maintenance windows. And I'm not going to say why, you can use your imagination, but people are on their computers watching their computer at 2 a.m. It turns out that it was a false belief to do maintenance windows after midnight. We did an analysis of a major Asian customer. We looked at their network traffic for 1 month, all the traffic traversing their network from client port to client ports. And what it turned out was 2 in the afternoon to 5 o'clock in the afternoon was the ideal time for this customer across the entire network to perform maintenance windows. Not midnight, not 2 in the morning. Their peaks, their valleys were at 2 in the afternoon. If I had machine learning to anticipate that, it would route the traffic around the event and I would do my maintenance activity. But what about threat tolerance, threat monitoring tolerance? What about threat monitoring? Cybersecurity is huge. We all know that. Security to me is the next, hidden war. It's taking place. We're all fighting for supercomputes. Why? Why is the US government funding all these supercompute initiatives? Why is China funding all these supercompute initiatives all over security? Who's going to break AES 256 first? Well, why can't I leverage my cable as a sensor and have threat monitoring? Why can't I anticipate an event taking place in my network? Why can't I classify an actual intrusion into my cables? Why can't I use it to predict a DOS attack on my network? They all have patterns. If you have a pattern, I can learn. Why can't I do nonlinear compensation? Now, I say all these use cases for a specific reason. The main reason I say these use cases, they're available today, they're doable. There's multiple POCs where we can demonstrate these use cases. For example, in a virtual assistant, why can't you ask the network, can you provision 800 gig wave for me? Why can't you tie to an automation platform and have it provision it for you? These applications are taking place and they're happening now. Now, in the post-Shannon limit, we need new ways to bring capacity. We need to overcome the demand versus capacity issue that we're facing. We overcome this by allocating more spectrum. We overcome this by doing SDM cables. We continue to investigate new spectrum. We continue to investigate the S-band. We continue to investigate new fibers. Backhaul needs to be more resilient. You heard it on the call in the previous panel. I think each and every customer brought in resiliency. We need to have the optical terrestrial network mixed with the metro network, mixed with a submarine network, all as one network. And we need to take advantage of AI. AI isn't just producing bandwidth. AI is going to generate, as we said, a boatload of bandwidth. But it's not just about the bandwidth it generates. AI is going to bring operational simplification to the network, enabling new levels of efficiencies that are going to save us dollars, power, and space. With that, I'm going to say thank you. Questions, comments, disagreements? Am I full of it? Oh, this is way too quiet. Thank you so much, guys. Appreciate it. Oh, too late. No, I'm sorry. I'm sorry.
Just one question. When you were talking about you effectively have to defrag your network, does that mean it's the whole network and not just the portion that you want to defrag?
It's
And is it hitless?
so that's an interesting topic and a disagreement I have with my team on a regular basis. I believe you want to run a defragmentation across your network. And the main reason I say that, as I turn up new services, I don't want to turn up new services on a fragmented network because I'm going to be back here redoing it. If you look at existing technologies today or existing techniques today for defragmentation, typically what they do is I want to light up a service. I can't get that service through. So then I'll defrag that section to enable that service. But all you did was delay the inevitable, because I don't believe customers are coming anymore, end customers, and asking for 100 gig wave anymore. Like I said, that US customer just got a request for 300, 400 gig E's. I'm not going to run a defrag on each of those wavelengths. I'm going to defrag my network. I'm going to leverage the predictability I get with AI, and I'm going to try to be sure I won't be back there again to defragment the network. Now, is it hitless? With today's technologies, by leveraging automation, I'm a big believer in SDN. Has it come to fruition? Maybe not. But I'm a big believer in SDN. I believe when you control the network via APIs, if you truly have an API-driven network, back to the open networks, I believe I can shift traffic in an elegant way away from where I'm going to do the free defragmentation. For example, if my service is on a router, I can increase the cost of that port in an automated fashion to move the service off that port, defragment that wavelength, bring the service back, remove the affinity flag from the port, bring the service back. Now, is that a longer process? Yes. Is it hitless? Very close to hitless. But I'm not doing it every day anymore, or every week, or every month. I'm taking my predictability of the demands and I'm fragmenting based on that, defragmenting based on that.
Cheers. Thank you.
Yep.
Thank you. Johan Jovi, Analysis Mason. So I thought it was interesting to see the extension of the optical domain from the cable landing station into the data center instead of having the CLS directly in the data center. But there's typically in the region, what I've seen is that there's some regulatory challenges to having, in particular, the PFE and some of the equipment which is meant to be in the CLS and sort of extending the optical. So how have you looked into this? I mean, it looks like you have. So what can you say about it and the applicability to the region?
So I think it's challenging for the region because of regulatory, different things such as lawful intercept and the likes. I do believe there's ways around that. You can do port mirroring. We just have to look and can show the regulators that the same process, the same functionality that they're doing today can be achieved by doing things such as port mirroring, that they can still get the same benefits of what they get from doing that. And it's a change. Like, I believe not only that's going to change, I really believe how you build your networks in general outside of the cable landing station to the terrestrial. I think in the next cycles of network evolutions, we're going to see major changes. I think that's one change we'll have to see, that we'll have to address. And I also think just the way AI is driving inference, inference, everybody uses all the buzzwords, right? So, you have your data center containing your training. So basically my study material for my test. Then I have inference. Inference is me taking the test. Now, inference will be distributed in the network, in my belief. Picture your phone. You have Apple, their new AI application. Well, user experience is the #1 thing for Apple. Think your autonomous vehicle. I don't want to delay in reporting that I better hit my brakes, right? You're going to move inference closer to the customers. That in itself is going to change how you look at networks, how you build networks. And I think that regulatory issue is just one of the hurdles that still has to be overcome. Do I think it can be? Most definitely. I believe the technology is available today. There's people in this room who've actually looked at us already and have ways of doing it, but it's having the regulatory bodies change the way. I think a lot of the stuff we're talking about here is changing mentality. I think we get used to doing things a certain way. I've done OTN switching since 2004, and that's what I know. It doesn't matter if it's efficient or not. That's what I know. We need to change our mindsets and build networks for tomorrow, not based on what I did yesterday. Thanks for the question. I hate cameras. Thank you, guys. Oh, sorry. Was there a question? Sorry, I apologize.
Thank you very much. Very quick question. When it comes to the AI traffic itself, so there will be a drastic increase in data centers. Now, if we would shift the question towards how can we use AI itself to manage the routes of traffic itself?
So again, I believe AI applications are key. So the thing with AI, though, is I think people think of AI and AI is going to solve all these issues, right? It's like if you think about it, 2010, we all talked SDN. At the time, SDN extracted sunlight from cucumbers. It did everything that wasn't possible. SDN did it for you. My concern is when we talk AI, we fall into that same trap. To me, AI is going to answer a question. I'm going to ask it a question. It's going to give me a response. The key underlying component to any AI architecture will require an automation platform. An automation platform that brings planning, that brings digital twins, that brings network management, and then a large language model on top built on agents that provide contextual models. In our case, optical contextual models or network contextual models. Based on that, I'm going to leverage AI to optimize my routes. For example, we mentioned the defrag. I'm going to anticipate my future growth so that when I provision my service, I'm going to anticipate that in the next year, I might have 5 more wavelengths that's going to be required across here. But at the same time, I'm going to start playing with my margins. I believe that we put too much margins in networks. You're going to have the vehicle with you to actually anticipate and look at past, to anticipate how much margin do I really need. And then I can get another optimization rather than taking my service doesn't need low latency. Well, I can turn away 1 or 2 dB of margin. I can take a longer latency path across my network. So I think network optimization will be one of the key aspects of AI applications. And then I think it starts at the design phase. I think even how you design networks with AI is going to change it because I'm going to design it based on my real network and my past learnings of all my traffic. Did I answer that?
Yes, it does. Thank you very much.
Do you agree? You can't ask another one until you agree or disagree with me.
Forced to agree. But a follow-up question on that, because there will be a growing demand on AI applications, right? We have yet to see any AI applications that would do such things yet. And we would have, let's say, intent-based AI application and so on. But how do you foresee data centers being able to handle these applications that will require such large investments moving forward?
So I think that's a two-pronged question. And one thing I hate in conferences, in fact, I was talking to Alan about this earlier. One thing I hate in conferences is when someone says, well, at Infinera, we have this product. I don't think that belongs at conferences. That being said, there's a demonstration that can be shown to you where you can interact with your network, asking it based, what was my past traffic? Can I provision 100 gig service from here to here? Can I provision an 800 gig wavelength from here to there? Now, the company that offers that demonstration, I'm not going to give its name. Just because, as I said earlier, I don't like it when people promote their company at panels. But those applications exist. But what it comes to is I don't believe those applications will reside in public clouds. I believe those applications will reside in your private cloud because you're going to train that with I believe in contextual models. A contextual model is going to leverage a large language model like a ChatGPT. And then I'm going to, what's the word? I'm going to add to it some optical networking context. And the network data itself will reside in my private cloud. That way, I don't have any data privacy issues to worry about. Because in the end, you're going to leverage services, your customer services, and they're not going to want you to have that in a public cloud. So those services will run in your private cloud. And so I believe the applications will as well, because those applications need to run on top, in my opinion, of an automation platform. The automation platform is the key underlying aspect to delivering, in my opinion, real solutions.
Actually, I like that answer. I don't want to take more of your time, but a closing note, especially when it comes to time to value, introducing any new kind of AI application, if you would propose to an operator that they should invest also in their own data center to have their information in their private cloud, wouldn't it mean that the time to value will be a bit longer? Because not majority of the operators aren't ready yet to have this kind of infrastructure.
See, but that's the beauty. That's the beauty of the solution. The beauty of the solution is the fact that I'm going to leverage the public cloud for my own personal data based on the application I want for the problem I'm trying to solve or optimize. I'm going to collect that piece of data. Now, that means I don't need to go out and invest in a massive data center. I can go buy today's 1RU servers. I can go buy a 1RU. I don't even need GPUs theoretically, because I'm not doing heavy computational compute. I can use a GPU, I can use a TPU, and theoretically I could use an array of CPUs. I would prefer the GPU or TPU approach, but theoretically you can do that. You're not forced to the time of value to be extended because you're building around your optimization and your pain point.
Wonderful. Thank you. Thank you.
Thank you. I appreciate the questions. And I like the fact you agree with me. So I like that part more. Thank you so much, guys. I appreciate your time. Thank you.